Let us start our class today. We will consider the moisture content of the air. Yesterday we have gone through, day before yesterday, we have gone through the heat and moisture losses from the human body. Now let us consider what is the moisture content we are supposed to have in the air. Now, we have seen in our earlier discussion that we know the dry bulb temperature, relative humidity, and air motion are interrelated. We know what is vital temperature. It is the temperature of a dry air which contains negligible amount of moisture, and relative humidity is for a mixture of air and dry air as well as air vapor mixture, the amount of the moisture actually contains in the air in terms of, say, in gram or in kg, divided by the amount of moisture which is supposed to be present in that particular mixture in the same pressure when the pressure is fully saturated, means fully saturated, means when this particular volume of air vapor air mixture is fully filled up to with the amount of moisture which is supposed to have there. Now another is, now what is the motion? And next question is the amount of air motion, means the amount of air volume of air coming in and going out from the air conditioning system. And all these three are interrelated. We have already admitted. Now the moisture content of air outside your say room during the interseason is generally low, and it is about the above the average during winter. Just a second. Because its capacity of the air now the moisture content of the air during the winter, is generally it contains less, and it is above the average above the average during summer. So what is very clear, it is our experience tells us in the winter condition, in winter, moisture content is less in in any volume of air, and in summer condition is comparatively more than the average during the summer. Now, the capacity of the air to carry moisture is dependent upon its dry bulb temperature. Now, what is this dry bulb temperature? Means we know what is the temperature of the moisture, the point of the air. As the moisture content in the air is dependent to a good extent on its temperature. So it is depends on the dry bulb temperature. That means that in winter, if the cold outside air having a low moisture content leaks into the air conditioning space, it will cause a relatively humidity and less low humidity unless moisture is added to the air of the in the process of humidification. So in some winter condition, what happens when the atmospheric air contains less amount of moisture, if he has a chance to come inside your room, it will reduce the relative humidity, means the amount of ratio of the amount of moisture present in this particular volume in comparison to the saturated, in comparison to the maximum amount of moisture which this volume of air can contain. So that is relative humidity, which is supposed to be less in comparatively low dry of the temperature. Now, unless add the moisture, this low relative humidity or less amount of moisture present in the incoming air will exist. Some of the reverse, always it will be exactly reverse. It will take place, the moisture, unless it is removed, it will have excessive amount of moisture in the air inside your room. So in the initial stages, you have to do the humidification, and in the final stage, you are supposed to do the dehumidification process. Now, while designing an air conditioning system, the proper dry bulb temperature, either summer or winter, must be selected according to the practical consideration of relative humidity which are feasible. So first of all, we have to understand what can be the maximum relative humidity, when the maximum moisture content in comparison to the saturated condition, and you have to create the proper dry bulb temperature or select the proper temperature for either summer or winter. And in general, the winter condition in the average residence, relative humidity is about 30 to 40%, and the moisture content is around 30 to 40% of the maximum content. So here, maximum content in case of saturation, and generally, in winter condition, it is the moisture content should be 30 to 40%, and not more than that. It's practical. But in summer condition, there our occupied space should not have a relative humidity more than 60%. So during the summer condition, the moisture content in your concerned area should not be more than 60% of the maximum content. And relative humidity generally, it is not possible to have 35 to 40% in winter condition, the 30% of the maximum content in the winter condition. So with this limitation, the necessary dry bulb temperature for the air may be determined from the comfort chart. So you have to select, in order to make the moisture content, in order to make our required moisture content, we have to maintain the dry bulb level accordingly. We have to select dry bulb temperature from the chart. Now, quality and quantity of air. The air in the occupied space should at all times are free from toxic, unhelpful, and disagreeable flames like carbon dioxide. Air should be free from such oxytoxic gases or disagreeable gases like carbon dioxide. It should be free from dust, audio, not bad audio, it's not healthy. It should not have maximum amount of carbon dioxide. It should not have dust. In order to obtain this condition, enough clean outside air must be supplied to occupied space to counterpart or regularly dilute the source of contamination. So there is one condition, contamination. Contamination is from CO2, from bad fumes, bad odor, and dust.
Sir,
বলো। হ্যালো, হ্যালো।
sir, what will be the stress point on an exam, sir?
What process? Too much disturbance from your side. Write down in the chat box. Too much disturbance from your side. Hello? Now what we are supposed to do is now let us go through. Next, the concentration of module means the bad smell in a room depends on so many factors such as maybe dietary, inhygienic habit of the occupants, type and amount of outdoor air is supplied, the room volume or occupant and type of audio sources, etc. So bad film, bad smell or audio, that can be so many things, maybe due to the bad practice of the occupants of the room, maybe some bad smell outside there with some bad smell supplied inside there, etc. So many things can be reasoned. If there is no smoking in a room, and there is 1 cubic meter per minute per person of outside air will take care of all the conditions. So one thing, there should be no smoking inside the room in a air conditioned room. So in that case, we don't need more than 1 cubic meter per minute. But if the smoking takes place, you have to need more supply of air, almost twice that of the non-smoking room, that is 1.5 cubic meter per person. The most air conditioned system, a large amount of air is reserved over and above the required amount of outside air to satisfy minimum ventilation condition in regard to wardability and purity. So higher volume of air required to be supplied in the room to clear all the bad smell or reduce, to clear all the smokes and clear all other toxic gases like carbon dioxide, etc. For general application, a minimum of 0.3 cubic meter of outside air per person mixed with 0.6 cubic meter of recirculated air is good. So we are not expected to supply the total fresh air to the room, but we can recirculate our earlier air, but we have to supply a certain amount of, say, 0.3 cubic meter, and we have to add the recirculated air around 0.6 meter cube per meter. The minimum values outside air is on cooling when will be given on the cooling load estimation. Next is the air motion. The air motion, which includes the distribution of air is very important to maintain uniform maintain uniform temperature in the conditioned space. No air condition is satisfied unless the air handle is properly circulated and distributed. So the distribution is important. Distribution and circulation is important. The air velocity in this occupied zone should not have 8 to 12 meters per minute. So speed should not be very high, should not be very less. Air velocities in the space above the occupied zone should be very high in order to produce good distribution of air. Provided the air in motion does not produce any objectionable noise, the flow of air should be preferably towards the face of the individuals rather than from the rear in the occupied zone. And also perfect distribution of air in the air conditioned space. Flow down should be preferred instead of flow up. So there are so many things we have to consider. The vapor air velocities should be good. Air should be pointed. Should be pointed towards pointed to the face of the person, to the face instead of back, as well as should be from top to bottom, and downflow or flow from top to bottom is desired instead of bottom to top. Downflow is desired. And so the velocity in the room above the occupied zone should be very high in order to produce good distribution of flow, good distribution of the air in the occupied zone. The air velocity of the occupied should not exceed 8 to 12 meters per minute, but should be in the occupied room. But velocity in the space above the occupied room should be very high in order to make good and comfortable distribution of the preferred occupied zone. Also, for the perfect distribution of downflow is preferred. Now, air motion without proper air distribution produces local cooling sensation known as draft. So it will be the room will cool in a particular area only, not for the full area, and it should be that it is just simply because the proper distribution air or proper supply air is not ensured here. Next, hot and cold surfaces. The hot and cold objects in a conditioned space may be cause discomfort. The hot and cold and hot subject in a conditioned space may cause discomfort to the occupants. A single glass of large area when exposed to the outer air during winter will produce discomfort to the occupants. To the contents of the room. Let us go through one thing first. The atmospheric condition, atmospheric air contains 0.3 to 0.04% of volume carbon dioxide and should not increase to 0.6%, which is necessary for proper functioning of the respiratory system. Carbon dioxide in excess of 2% dilutes oxygen. In excess of 2% dilute oxygen makes breathing difficult. When the carbon dioxide exceeds 6%, breathing is very difficult. 10% is a cause of loss of consciousness. A normal make rest of in breathing exhausts about 0.015 to 0.18 cubic meter per hour of carbon dioxide. So first, carbon dioxide CO2 is most important part, which we are supposed to avoid it. And we know that atmosphere condition has only 0.03% to 0.4% carbon dioxide by volume, and it should not be 0.6%. Actually, what happens, 2% dilute oxygen contents carbon dioxide in excess of 2%, it dilutes oxygen contents and makes the breathing difficult. If it exceeds 6%, breathing is extremely difficult, and 10% carbon dioxide will be unconscious. A normal man should exhale about 0.15 to 0.18 cubic meter of carbon dioxide, which is again making a problem to the person concerned. Now, the occupants of a room is absorbing heat from them by radiation. On the other hand, a ceiling, what is that? The cold or hot object. First of all, this one, either a very cold objects or very hot in the conditioned space may be difficult discomfort. Means a single glass of very large area which exposed to the outer air during winter will produce discomfort to the occupants by absorbing more heat to them by radiation. But on the other hand, ceiling that is warmer than the room area during summer causes discomfort. So thus in the designing of the air conditioning plant, the temperature of the surface to which the body must be exposed may be given comfortable importance. So the presence of hot surface, hot objects, objects or cold objects in the in the particular room will cause discomfort from your side, from the occupant side, because you see, say a large glass, a single glass of very large area exposed to the outdoor of the air during the winter will cause discomfort to the occupants of a room by absorbing heat from them by radiation. So in winter, if we have a very large glass producing keeping on one side of your room, you can absorb the heat. This glass will absorb heat from the outside of occupants by radiation. If the ceiling is say very warm during one way is very warm than the room, during the summer, it also causes, ceiling is very hot, it will cause the heat to transfer inside the room and it will cause you discomfort. Now, the temperature of the surface to which the body is exposed to must be given considerable importance. Now, air stratification. When air is heated, the density decreases and thus it rises to the upper part of the cool space. This results in considerable variation in temperature between floor and ceiling levels. The movement of air to produce the temperature from floor to ceiling is termed as air stratification. Movement of the air, if the air is heated, its volume, its density reduces and causes it to move up or to the confined in the upper half of your constant place. But this type of movement of air to produce a temperature gradient or change in temperature gradients from floor to ceiling is known as air stratification. In order to achieve the considerable condition in the occupied space, the air conditioning system must be designed above to reduce the air stratification to a maximum. Now the factors, so the movement of air from bottom to top is an important factor. That's also which is defined as air stratification. This to produce this movement will produce temperature gradient from the ceilings, means temperature variation, rate of change of temperature from bottom to top, and this effect is now called air stratification. The important factors which affect the optimum effective temperature as follows: climatic and seasonal differences. It is known that people living in colder climates feel comfortable at a lower effective temperature than those living in the warmer regions. So the climatic and seasonal differences. Now, colder climates feel comfortable at lower effective temperature than those living in the warmer region. But that is a relation with the optimum indoor effective temperature and the optimum outdoor temperature, which changes with season. Now, We know from the comfort chart that the winter, the optimum effective temperature is 90 degrees centigrade, summer is 22 degrees centigrade. So what is it telling us? The seasonal difference. In part climate, it differs, the temperature changes from climate to climate, season to season. How the people living in cold climate, it will be felt comfortable when lower effective temperature, and those in the warmer region. This is a relation with the optimum indoor effective temperature and optimum outdoor effective temperature. Optimum indoor effective temperature maximum and optimum outdoor temperature, which changes with season. So, we can go through which changes, go through that chart, which is in winter. The optimum effective temperature 90 degrees centigrade, by the summer it is around 22 degrees centigrade. Just a second. Next is the clothing. Next is the clothing. It is an important factor. So, which affects the optimum effective temperature. May be noted that person with light clothing need less optimum temperature than the person with heavy or hot clothings. Next, age and sex. We have already discussed the women of all ages requires comparatively higher temperature, about 0.5 degrees, and men is all requires higher effective temperature. Similarly, as in the case of young and old people, the children also needs higher effective temperature than adults. Thus, the maternity halls are always kept at temperature of 2 to 3 degrees higher than the effective temperature used for adults. So, ladies are required at more effective temperature or higher effective temperatures around 0.5 1 degree, 5 degree to 1 degree above the man. Similar is the case with young and old people. The children also need higher effective temperature than adults. Thus, the maternity halls are always kept at a effective temperature of 2 to 3 degrees centigrade higher than that. So maternity halls are kept at higher temperature. Ladies requires more effective temperature than the men, and also children. So all these places like maternity halls, we keep it comparatively higher temperature, not very high, but around 0.5 to 0.1 degrees centigrade than the surroundings. The 50 were the adults. The duration of stay. It has been established that if the stay in a room is shorter, then higher effective temperature is required, and this is for small stay in case of persons working in an office. So, if you stay in the room is less, is short, then the higher effective temperature is required. If you stay more, then comparatively less effective temperature, higher effective temperature is required. Next is the kind of activities. What we are doing inside the room. One the activities is heavy, such as people work in a factory, dancing hall, then low effective temperature is needed for the people sitting in cinema hall. So, which is working hard, which requires we requires less effective temperature than the people sitting cement wall and doing nothing. The density of the equipments, the effect of body radiant temperature from person to person, particularly in a dense occupied space like auditorium, is large enough, which requires a slight lower effective temperature. So, how much the body radiant from person, it also varies from person to person, and especially in a dense room, dense occupied space, the auditorium is large enough, which requires high lower temperature. Lower effective temperature. So what you find here, what is the factors? Means climate. In climatic, the temperature changes. Climatic changes. Your clothing may change the temperature. Clothing changes according to age and sex. Ladies require more, ladies and children require Radiation chamber requires higher effective temperature. And there is the duration of the stay. If you stay comparatively less amount of time required comparatively lower effective temperature than if a longer stay or long stay inside the room. And what exactly you are doing? If you are working very hard, you require lesser effective temperature than if you are only sitting idle in a cinema hall or some auditorium. And effect density of the occupants, the body effect of body radiant heat from person to person varies. In a densely occupied space like auditorium, and it is large enough which requires higher lower effective temperature. Now, what is the inside summer design condition? So outside ground temperature is given here, it's 26 degrees centigrade, 29 degrees centigrade. So occupant over 40 minutes, occupant below 40 minutes means those who are staying less, and they have also there are other categories we are making those who are staying more. So dry bulb temperature, wet bulb temperature will varies. Wet bulb temperature, relative humidity, and effective temperature is given here. So DBR is comparatively less than the out surroundings. Wet bulb temperature are another less, and same is the case with say this case with 29 degrees centigrade, and this is the arrival temperature, three different position, the wet bulb temperature and the dry bulb temperature secondary line. So this is the chart. It is telling us all these details. Next, the outside summer recording condition. This earlier chart is giving us inside summer design condition. So what will be the, as per the outside dry bulb temperature, what is supposed to be the inside wet bulb temperature. Next, we consider the outside summer design condition. When following table gives us the outside summer condition, what will be the outside for important city, and what will be the outside dry temperature, wet bulb temperature, relative humidity, and effective temperature. You see, we have the higher temperatures more than 43, or like Ahmedabad, Ambala, all these places, and all other places are more or less for more than 40 cut. But Alibag squares less. Same is the case with wet bulb temperature. Then Cochin, Cambodia, they are always giving us less amount of design outside temperature. And so many variations are there. Of course, everything. When the Rajasthan and Western India carries higher amount of heat in terms of the northern heat, and same is the case with wet bulb temperature and relative humidity. Next. So this is the more or less comfort conditions, discussion about the comfort conditions. Next, let us go through the discussion about the cooling load calculations. Let us start this introduction. Now, total heat required to be removed from the space in order to bring its desired temperature by the air conditioning system is defined as the cooling load. So the amount of heat we are supposed to remove from a particular space in order to make a desired temperature. This is known as so it's known as the cooling load. The purpose of the cooling load estimation is to determine That's what is the size of the air conditioning and refrigeration equipment that is required to maintain the inside design condition during the process of maximum outside temperature. So what can be the maximum temperature glass we have to understand. Next, we have to find out what is the size of the air conditioning and refrigeration system to maintain the desired inside design condition. The design load is also based on inside and outside design condition and the air conditioning and refrigerating capacity to produce maximum satisfactory load conditions. So first we have to know what should be the temperature to make our inside the room and to make this make our room comfortable, and what should be the maximum temperature outside the room to make this which we have to reduce in order to make our inside the room comfortable. Now, components of the cooling load is two main components are of a cooling load is imposed on an air conditioning fan operating hot water as follows. This is a sensible heat gate where there is a direct addition of heat to the enclosed space. Again, in the sensible heat is said to be occur. So if you directly apply or brought or absorb certain heat, it will be a sensible heat application. This is to be removed in the process of summer, and the sensible heat may occupy due to any of the following reasons. The heat flowing into the building by conduction through the walls, floors, ceiling, windows. Heat received from solar radiation. It consists of the heat transmitted directly through glass of the windows, ventilators, and doors. And heat absorbed by the walls and roofs exposed to the heat absorbed by the walls and roofs exposed to the solar radiation, and on the transfer to the room by conduction. So what is the solar radiation? Heat flowing into the building by conduction through external walls, floors, ceilings, everything. And heat received from solar radiation, from the outside temperature, from sun. The heat transmitted directly through the glass of the windows, ventilator. Heat can be absorbed by walls, roofs. Heat conduct through interior partition from room to room inside building. Heat given by lights, moisture, by motors, machineries, etc. Heat liberated by the occupants, and the heat carried by the outside air will leaks in the infiltrating air. Though the cracks in the doors, windows, and through their frequent openings, the heat gained through the walls of the ducts carries conditioned heat, carrying conditioned air through the unconditioned space in the building, and the heat gained in the fan wall. So, first of all, how much heat is coming inside the room through these walls, ceilings, etc., walls, ceilings, doors, etc., and how much is we are releasing directly from the heat. That's also true from windows, ventilators, room doors, etc. And the heat absorbed by walls exposed to radiation later transferred to the room by conduction. Means the walls got heated, and then that heated wall is transferring the heat to the room inside. The heat contacted the interior partition. The interior partition may be between a hot room to a cold room, and it may be because of the steam flowing from the room to room, and say from unconditioned room and from non-unconditioned room. Heat given up by lights, motors, machineries, and industrial spaces, etc., which is when light motors, we hear what is generating and what is giving away. The heat liberated by the occupants. The occupants also coming from outside, having certain amount of heat on his clothing, and it is liberated by the occupants inside the cold room. Next, the heat carried out by the outside air, which leaks in, infiltrating air. Now, some air is starts infiltrating in the room, maybe from the outside, and it's pretty hot, maybe through the cracks, some door openings, or when the door are open to somebody is coming in or going out, etc. Or some windows, some portion is open, and through their frequent opening, some heated air is come out from the outside, is coming inside the room. Then through the walls of the ducts carrying conditioned air, that's also through walls of the ducts which leaks in the air through the cracks in the door, windows, and through their frequent openings. The heat came through the walls of ducts carrying conditioned air through the unconditioned space in the building. Then the heat came from the fan work. The fan is running in the room. It's also creating some amount of heat due to its motor in the motor, which is also remains absorbed in the room. The heat came through the walls of the ducts carrying conditioned air through the unconditioned space of the building. Then, so there are certain portions are unconditioned, unair conditioned, and there are certain portions conditioned. So the heat is coming in from the unconditioned portion to the conditioned area. This is the different source of heat. So this is the sensible heat we are gaining. And what is the latent heat we are gaining? When there is an additional water vapor in the area of the enclosed space, again a latent heat is said to be occur. When some water vapor is applied to the air, this latent heat, this water vapor, this will create some latent heat addition will be added. So how this latent heat is to be removed? It is to be removed during the process of summer air conditioning. This latent heat gain may occur due to any of the following cases like this. Say, heat gain due to moisture in the outside air. Heat due to moisture in the outside air entering the temperature. Heat gain due to the condensation of moisture from the occupants. So outside air has some moisture. That's also when during the time of coming in, this is also there with this moisture. The condensation of the moisture from the occupants. So moisture is supposed to be condensed and releasing heat. The heat gain due to condensation of moisture from any process such as cooking foods or takes place within the conditioned space. So some of the process such as cooking food will create certain heat, and which also we have to be gained inside the conditioned space. The heat gain due to moisture passing through directly into the conditioned space through the permeable walls or partitions from the outside or from adjoining regions where the water vapor pressure is higher, or partitions from the outside or from adjoining region where the water pressure is higher. The total heat load is removed by the air conditioning refrigerator equipment, the sum of sensible and latent heat inside the discussed above. So what you see, the sensible heat gain is coming from the directly from the outside air, and latent heat also that's also coming from the air in other sense, latent heat gain, because air has some moisture and it can be it can also some water particles which also get condensed. Like this, it's also releasing latent heat to the inside wall of the surrounding. The question is, when the outside air is introduced for ventilation purpose, there is also sensible heat also introduced, and it's also gained as well as latent heat is also gained. This sensible heat gain is now is due to the temperature difference between the fresh air and the air in the space. That's temperature in the fresh air and the air in the space, where the latent heat is due to the difference of humidity. Okay, this is we are stopping here.